Okay, very good. Okay, today we are going to talk about compression and why it is necessary and how it is done. You have all used the one form of compression with or without knowing. Most probably, the knowing one was the one that you use for zipping files. You zip the files, and the space that those files take is always less than or equal to the unzipped file. When they are zipped, the redundancies are basically being removed. So it's not magic. How come we have a video file of 1 GB and we zip that, or um, we convert that to another format, and suddenly it decreases to 50 megabytes? What happened? Where did the rest of the thing go? These are the topics that we will discuss today. Before that, there is a link here. You can click and see it. It will take you to a website that you will be able to increment and decrement your input with a key that only you know. So you can uh, put any text you want, and with that key, that will be incremented. So this one that you see here, if you click on this and put this text file compression and blah blah 321 backup. If you go here and for the key choose 256-bit and then put the decrypt, you will see that um, this will be this text will be encrypted to this text, which looks like some gibberish, but this is how it is. And by the way, you see that it's probably shorter. So the algorithm behind that, how it works, and things like that, we will talk about. And this is the agenda of this week, in the form of encrypted files. Basically, this is this text. What and why and how we do the file compression, um, how it affects data transfer. Is there any drawback? Um, Overview for the formats, different formats, and we will learn with which type of compression we lose some of our data, and what are the lossless compression algorithms. And then we will discuss uh, backup stuff. We will see some more details about how this backup is done, and you will be doing some more stuff in the activity. In the activity, we will explore more file compression, and you will do that manually basically to learn how compression works. In this activity, you will be the zip software that zips these files. Then you will work with some image factors, image compression stuff, and then the third part is working on backups on OneDrive. A useful activity, I think. So the concept of zipping is not new, and it comes from the fact that we can delete the repeated stuff. So instead of showing four pink rectangles here, five green rectangles, and three blue rectangles, you can always get rid of the redundant parts and show them like this. Obviously, if we convert this to this, it takes less space. Let me check on this. Okay, you will see less. Now, so now that this idea seems good enough, why not go ahead and use it for uh, our files? So, uh, file compression is a process after which the compressed file has less than or equal size to the uncompressed size. And can somebody unmute and tell me why I'm saying less space or same, less than or equal space after zipping a file? Somebody please, some brave person, unmute himself and say what he or she thinks, or otherwise I will need to select a person. The question, so one more time, the question is, we run an algorithm to compress a file. Is there a chance that the size of the compressed file is exactly the same as the size of the uncompressed file, or no, it always goes less? It always less. It always has less file size after compression. Somebody. Okay. Select a random user. Abdullah Elhaq. Your name came up. Are you there, Abdullah? You're Abdullah. Gurmahak. Are you there? Gurmahak. You're also don't have mic. Guys, please use mics. Uh, Kefi, are you there? Okay, so is it possible to end up with the same file size after compression, or no, it always reduces the size? What are your thoughts? What do you think? Very good. So, in what condition do you think a file is not compressible anymore? Okay, that that's what we agreed on. Now the question is, thank you, Sanjana. Now, what do you think? What was the possible condition that that WinRAR algorithm couldn't compress that file basically, and the output has the same file size as the input? Okay, so yeah, I this was actually, you could guess, but this is the topic that we are discussing today. So thank you both. Thank you so much. So the compressing is basically finding the repeated stuff, repeated characters, repeated files, repeated piece of code, and anything that is repeated exactly. It is it is it is copied, basically copied and paste. Even if you look at this text, how many s do you see here? How many f's do you see here? How many a's do you see here? every time that something is being repeated, there is a chance that we can compress it and reduce the size. So for the files that after zipping, the, the file size doesn't decrease, it means they either, which is less probable but still possible, they they either don't have any redundant data, nothing is copy and paste, or the format is already a zipped format. For instance, JPG is an image format that is already reduced, that is already compressed. The redundancies have already been taken care of, so there is no redundancy. So if you zip a file, Naveen also replied to this. If you see a file, yeah, he says this file is already compressed. Yes, that's the answer. Um, if you compress a file, compress a JPG, go ahead and do this. An image file, after and before, there will either be no size change or there will be very insignificant file size change uh, because JPG is already compressed. So if a file doesn't have any redundancy, that's basically not compressible anymore. But that's not compressible, that might be still compressible with some newer algorithms. That's why this is a hot topic, not a hot topic, but this is an ongoing research to find more efficient algorithms that can compress files to even smaller sizes. So if you come up with a better algorithm, that the file that was not compressible anymore with WinRAR might be compressible, and you can translate that to money. And uh, we have different file types when they are zipped, and an archive when it's coming to zip. You know, an archive, when you open an archive, it's the compressed files and folders in it, so you can decompress that and you can use that. Another, we will see examples, by the way. We will see examples here. Why file compression is useful. One thing that we discussed is it reduces the size, so that's what we like. We like to uh, have smaller size files. Why? For two reasons. You either want to store those files, so you you can store more files in a fixed size space of hard disk drive, for instance. You can keep more things in it, or you want to transfer that file, you want to upload it somewhere, or you are downloading something. So when you're uploading or downloading something, your you will be faster, right? This is one of the good things about file compression, and that's why you always all the time, almost always all the time, you have to compress your files before uploading to a server, and the server also compresses the files and sends the file to you typically. So gzip and so many more complicated zipping algorithms that is around, they are there because these days everything is on servers, and if if we if we can make files smaller, we will benefit a lot because of the limited traffic that we have. uh, it will be faster, and that's a big benefit. Also, while we are reducing the size, we are zipping these files. 99% of the time, an encryption algorithm also kicks in. So not only you're reducing the redundancy to make the file smaller, but also you are encrypting that. Uh, and by encryption, we mean you are changing the way that file will be read, and the only person that will be able to decrypt that, to see the real understandable um, file, text, or whatever, is for the person that has the key. Using that key, that encryption happened. So this is another benefit of zipping files. For instance, in WinRAR, there is a password protection, or there is an encryption file. Do you want me to encrypt this file? Give me the key. So you can give the key, that will encrypt. If somebody receives that, even if they know the password and they open the file, they will see gibberish unless they have the key and they can decrypt that. So compression is very helpful. Um, we can There are a couple of well-known, well-established algorithms and mechanisms for compression. Uh, one of the very uh, popular ones, as we discussed, is you go ahead and find the repeated stuff, the duplicate strings, as in this slide says, um, in a text, and convert them to a pointer. We will see an example. So what happens, for instance, in this case, what happens if I take out all the A's, okay, I say A, wherever I see, I go ahead, I read this text, and wherever I see A, I take that out and just put a dot or put a star and say, okay, Mr. Decryptor or Mrs. Decryptor, when you are decoding this, in the process of decryption, now you should read, and whenever there is a dot or whenever there is a star, you replace that with this A. This way you make the text again, but by getting rid of all those A's that we have here, and only keeping one A, we literally reduce the size of this by you don't need to keep that character anymore there. It can be a placeholder, which takes less. Maybe instead of instead of 32 bits or 8 bits or whatever, you only need 1 bit to keep that data. So this results in uh, size size reduction. And also we can so another algorithm is replacing symbols with new symbols, or based on the frequency of their use, we can play with them a little bit. Now we will see examples here. Let me wait a second. I want to be able to. Oh, it's here. I want to be able to play this. Me. Where is this right here? Okay. What I can do is, um, let me see. Can I stop it? Yeah. Okay. Now let's run it. See, bills, ILLS is repeated here. ILLS. Okay. Take out. Because it is repeated here, you take it out. Now put a dot here instead of ils. Now we know that this circle or dot or whatever, a placeholder, uh, this placeholder is for ILLS. Now we had four letters here. That was 32 bits of information, and we could change that 32 bit of information to 1 bit or something that is much smaller than that. Now go ahead. Now this is the again now this is again what has been repeated here. This is the exact same thing repeated here. So why keep this? We don't need to keep this. Take this out and put another placeholder here so that we know this will be repeated here. And again, the same thing repeated here. So take that out. Now we have only four placeholders, and redundancy decreased by counting the number of letters that is used here uh, at the beginning, and by counting them now, you can see that this is almost half of the letters are gone. Half of the letters were repeated, so they are gone, and instead of that, we have placeholders. So this is how a compression happens. Now the compressor gets this, which is only 56.2%, sorry, is about 53.8% size of the original file, and plus some placeholders. These placeholders are insignificant. These are just placeholders, and uh, you know uh, what we can place where and what we can place. Do you want to watch it again? Let me play it again. See, first find like ills, put it there, wherever you see, and then go ahead with the next redundancy. Go ahead with the third redundancy. Wherever you see a redundancy, you get rid of that redundancy, put a placeholder, and that becomes the compression. Do you have any question about this? Any question about this form of compression? No. Okay. Simrat, Jai, Abdullah, Gurmahak didn't reply. And um, now, when it comes to decoding and uh, decoding something, again, there are algorithms. Now, you see that now we are going to decode the encoded uh, information. This is the encoded information. It's a bunch of ones and zeros, and we know that this is the key, uh, and we know that this is an encrypted form of a text. Let's see now if we decode this. The first, we first start with this one. It says the first block asks, is it 1 or 0? It's 1. Okay, then so go to the next block. Is the next number 0 or 1? It's 0. Okay, so it is L. So this represents L. What else? Again, from the beginning. Now, after this, again, we go back to the beginning. What is the first number? 1. What is the in this block. What is the next number? Again 1. So go to the other block. What is the next number? It's 0. So it's an O. So 110 is an O. Let's guess what this will be. This is just a 0. So in the first block, it's 0. It will be S. S. Again, this one, 0, it's another S. 10, it will be 10. It will be L. 111, 111 is E. 0, again S. 0, again S. So this was simply the encrypted format, which also it's not only encryption but also size reduction. So many encryption algorithms also reduce the size, which is the beauty of those algorithms. Now imagine we have here 8 characters, right? 8 characters. Each character takes 8 bits or 1 byte. It is 64 bits, but we could compress that to only 14 bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Only 14 bits, zeros and ones, 64 bits to 14 bits reduction, which is a significant reduction. So we have two type of algorithms. Some algorithms sacrifice some of your information. They get rid of some of those information um, to make to make it smaller. And by the way, that reduction should be in a way that it doesn't destroy the main take-home message of that file. It typically happens in image, audio, and video files a lot, a lot. Um, have you seen singers singing in those large microphones, like when they are in the studio recording a song? They use special mics, very large mics, with some kind of uh, some kind of net in front of them to get the noise and everything. Those mics are very wideband microphones, so the signal that is coming from those microphones um, has also also very high pitch, very high pitch frequency elements of the voice of the singer. But you and I, when we want to listen to that song, we don't really need that high quality to enjoy. Even in my speaker, even if I played the music file of like that huge music file size that has all the details, all the frequency details of the singer's voice, my speaker will not be able to play that because it has its own limitations. So why bother and why store large audio files, and why waste bandwidth on the things that people will not even hear? That's why MP3, MP4, or other audio file formats that came into play. And they basically get rid of some of those information without really decreasing the quality. Of course, some part of the quality is sacrificed. They read the song is recorded in the studio with those mics and everything because that's the source file, and they want to keep everything. If one file is a large file, it's okay, but if millions of people are going to use that same file, it's better to get rid of some of the parts that will not destroy the quality. It will just a little bit decrease the quality, but it's enough, and we benefit from file size reduction. Many of image, video, and audio encryption and compression format algorithms are lossy, so you will lose some data. On the other hand, typically uh, for for text and for things that you need to know all the details, whenever you want to you want to compress and decompress without losing a single character, you need to use lossless algorithms. For instance, the algorithms that your WinRAR uses to compress the files is lossless, um, because if it is a if it is an MS Word file you are compressing, you don't want to see some of your images are gone or some of the text is gone after uh, you unzip that file. Here, taking a look at some lossy and some lossless um, sorry, file compression formats. Uh, so consider this the original file, PNG and TIFF are lossless. So you see a very high quality image um, without any decrease in the quality. And look at the size. This is almost 1 MB uh, bit, I think, kilobit, 941 kilobit image. And then with GIF, we make it so many of these, the information is lost. You are still able to see what the text is. You can, everything works fine. Like if it is, when it comes to distinguishing the letters and numbers and whatever, it's fine. It's not that destroyed basically, but you lose some of the quality of the image by doing GIF. And initial GIF is for those animated images. So you put many images and play them with a time step, um, and just show them, and that becomes an animated GIF. So you don't need, because the user will see each image in a fraction of a second maybe, or a couple of seconds. So the quality doesn't really matters. That animation matters. So this is, we can sacrifice some of the information to create that animated stuff. And also JPG is a lossy uh, algorithm. It works. The algorithm is works differently. It basically doesn't keep sharp edges. We call this um, low pass filter. So basically here, the sharp edges, you see the edges are not that sharp. So the high frequency elements of this image has been eliminated, and that is what happens in JPG. The colors are fine. Here you see the colors are sacrificed in GIF, but in JPG the edges are sacrificed. And each work, and depending on what you want, you can go ahead with any of these compression compression algorithms. Again, in terms of high resolution and low resolution images, sometimes the reduction is in the number of pixels that we have. So if you zoom in, you will see 1 pixel with the adjacent pixels being the same. So here, for instance, this is blue. All the adjacent is blue. So why not we get rid of some of these pixels, and that makes images smaller in size as well as smaller in the kilobyte size, and also smaller in the dimension. So now if we see the smaller, if we make these larger, we will see Now you see the quality of this has been decreased significantly. Why? Because we have merged, basically here we have merged the pixels that were similar to their adjacent pixels, and this way we have increased the size of the pixel, and that increase in the size of pixel results in this kind of blurry stuff. um, but if the length and width were smaller in the previous slide we see that quality is fine, but the images is slower and the kilobyte size is much smaller. And by increasing, you realize what has happened to this image by uh, this kind of reductions. But well, this is not okay. This is probably okay sometimes. So this happens in video files or video files as well. Yeah, video files and video and audio files, and sometimes image files. So in this slide, we see some of the compression formats. Zip is the gold standard. It's lossless, and it's cross-platform, and you can do this zip and unzip on different systems without any problem. So at the time of zipping, they become a standard file output, but when each file is being unzipped in on a platform, based on the file format that the operating system dictates to that software, unzip software, the file format of that operating system will be considered, and the unzipped file will follow that format. For music, the bolded formats are lossless. So whenever you see this is bolded, these are lossless. You see very little of those, especially in video. We don't have any lossless algorithm, because videos are really something that uh, you can really get rid of a lot of extra information that is only required for HD quality or 4K or 8K quality or things like that. But if you're watching it in a smaller screen, or you don't need that high quality, obviously all these algorithms which are lossy algorithms can help. Music also same thing. We said that there is a lot of extra information in the original music file, so you want to get rid of these. Some of these actually open the window of signal processing for some of you guys. If you are interested these days, actually there are a lot of job opportunities for implementing image processing, image compression algorithms, for audio processing, for all these under the category of AI. So you are an AI programmer, you develop an algorithm, or the algorithm is already there, and they want somebody to code that algorithm and implement that algorithm for video compression, or for uh, image recognition, whatever that whatever application that you can think of. There's a lot going on these days with all these smart cars and videos being processed everywhere, on online, on virtual media, YouTube, all these doing. So, like imagine the algorithm. Every time you upload a video to YouTube, it processes that video for so many things. Uh, so is somebody sitting there and watching your 2-hour video to see if there's something wrong with that? No, these are just algorithms. So how do these algorithms do that? Um, this is a hot topic. Of course, not compression. We're a little bit deviating from our topic, but I mean, in general, all these algorithms that frame by frame extract videos and do image processing and do all those good stuff. And for the data, now these are, see, now it's data. As you expect, everything should be lossless. You don't want to lose your data, right? The data is what you don't want to lose any part of it, and that's why for data everything is lossless. There should be a guarantee for the output of the compression algorithm when it comes to data, that it's exactly equal to its input file, or this can be, or the exact same data can be decrypted, decoded, unzipped, or constructed from the output of these algorithms. And for images, we have some lossless and some lossy algorithms depending on where and what size of image you want to use. Are we good until this point? Is there any question? Is there any question? So the question is if there is any question. Okay, good. Let's continue. Now, is there any drawback for file compression? There is. One thing is you need to burn CPU. You need to uh, use your CPU, use your resources basically to perform this compression and perform the uh, and for the and the vice versa. If you are compressing or decompressing, both ways you need to use some resources. That's one of the disadvantages. Imagine it's personal if it's your personal computer, you're good. But if it is a server and millions of people um are 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 uploading and downloading files, then you should really be careful about the amount of resources that can support that amount of compression and um, decompression. Space. Uh, you've seen that when you sometimes you download a zip file, now you want to extract that. You cannot extract because the zipped file size was smaller. You had enough space for that version. But when you want to unzip that, it's going to be a much bigger file and you need a larger space. Um, so that's another problem. Integrity, that's what we discussed. Integrity should be maintained. Uh, Even in lossy algorithms, integrity is important. So there should be a guarantee, at least some principles are maintained. In the example of the that text and the number that we saw with GIF uh, and TIFF conversion to GIF and JPG, we saw that you still uh, can easily tell the difference between the letters and the colors and all those. So this is the integrity. There shouldn't be any loss of significant data or significant portion when an algorithm is doing encryption or decryption. And obviously, recoverability uh, is the mechanism that things can be recovered uh, if basically you want to, for instance, you want to uh, recover the data from a lossy compression. There must be a mechanism to refer to the source file if somebody didn't want to do this. So reverting should also be possible with these algorithms. Um this is all we had. This was the last slide about compression. Is there any question about the compression? If not, we can probably uh, have a 5 minute break and come back for the backup part. Okay, we'll see you in, now it's 1:30. I'll see you in 1:35. 5 minutes break. Okay, okay. Let's see what we have in the backup part. Uh, for the reason we need backups, we have discussed this. We will see more details about backups in terms of algorithms of backup. But the main reasons are accidental deletion. So accidentally you can delete your files. Most probably, this is the main reason I lost. I was lucky that I had a backup for the last 5 years of my work, and I was really lucky I had a backup. But because of hardware, because of my hard drive failed, it was a bad sector, it was a terrible one, so I lost all the data. But I was lucky that I had a backup. Some other reasons: ransomware, other catastrophic events like fire, flood, less probable, but also possible. Some attacks, and many other things that you can think of. So backups are important. Um, for there is a RAID system. It's called RAID, Redundant Array of Independent Disks. So the concept is this: instead of storing in one hard disk drive, why not I make many of them in parallel and start storing um, the same data, basically mirror the same data in multiple storage spaces. And this is how RAID works. In RAID, there are different algorithms for different RAIDs, but the higher numbers basically keep some of these resources for checking the correctness of this mirroring. So basically they check if the mirroring, during mirroring the data, has there been any problem or no, the copies are the same. They basically make sure some of these resources make sure that the copies are exactly the same. Um, and the rest is just spare parts for storing the data. If something goes wrong with one of these, without you noticing that, the operating system will pick up the other resource. So you will not even notice that. You will know there is a problem in your RAID system, but basically the whole thing looks like looks like one thing to operating system. Looks like one resource operating system, and it can the operating system can access any of these at any time if the default uh, goes faulty or breaks. And um, we emphasize that for backups to be really backups, you need a copy that is stored in a geographically separate location and is not connected to your computer, is not dependent on your machine anymore. So it should be an exact copy, and it should be stored in a geographically separate location. If you're home, if you have your backup at home, it's not the it's not a very good backup that you have. Or if your backup is in your computer, it's not a backup anymore. It's not a good backup anymore, because in the first scenario, if something goes wrong, here a disaster happens at my home, basically I will lose whatever data I had. And in the second scenario, if your computer breaks, again you will lose all the data. We can get backups in two different scenarios. One of them is, okay, I don't want to back up the whole system every week or every day. Why? because there will be a significant portion of redundant information every time I back up the whole thing, right? So the idea is, why not, let's have a backup once, like Monday, let's have a full backup, and after Monday, the backup will only be the portions that have been changed or updated. So imagine you have 5 MS Word files. Since last Monday that you took a full backup, 4 of them are the same. So why waste time and resources for again taking an image of those Word files that did not change, that have not changed since then? So just take an image of the changed MS Word file. And so the strategy is, we have one full backup. It can happen anytime. And after that, all the backups are in differential mode, which means uh, only if a file is different from the file that you had like 2 weeks ago or last week in during that full backup, then okay, take a snapshot of that, also add that into my backup. This is a good way of doing backup, unless full backups become so distant, so infrequent. If you do the full backup frequently, they work. But imagine you had a backup in January, and since then you're doing differential. So every time you're going back and comparing your system to uh, the contents of your system to January and taking a backup of the difference. So since January, I've made a lot of changes to my files in my machine. So uh, that becomes a problem. But overall, if the full backups are frequent, um, this is a good method. Another method is you take a full backup, and then every day you come, you compare, you take the differential part only, you take the difference that happened between between today and yesterday, and when tomorrow you come, you don't compare that to yesterday, you compare it to the difference that you have today. This is a much better way of taking backups. The pros and cons in the previous one was that uh, backup is slower because you have to check all the differences uh, in a reference in a time in the past that can be a distant past. So it adds to the amount of things that you need to back up. It can be time consuming when it comes to backup. But restoring is easy because you have only the full part plus the differential part, just 2 files put together, and restore is fast. But here, taking backup is faster because every time you come, you are comparing the changes to a very close past. It could be yesterday, could be last week, so there is not much change. It's quick when it comes to taking backups, but it becomes slower when you want to restore those backups. Why? Now you have multiple files. During a during a year, if you did it every day, you have 365 files that need to be merged and be restored and make your computer uh, as it was uh, 2 minutes ago by restoring all these. So this restoring part is a bottleneck uh, in this strategy, in full and incremental strategy. Enterprise backup is a little bit more complicated. Enterprise has much more data than you and I as personal as people So they need to find uh, more complicated backups. Also, one problem in enterprises is that they have multiple users, and how to make sure, if I say, okay, I will do this backup of my whole entire system every 2 minutes, but how can you make sure that all your users are using the same software version? All your users are storing their data at the same place that you want to take a backup. So a lot of complexities come in play. Uh, One best way probably to do is to use uh, cold backup using these clouds. So if you buy, this is where buying a resource, as we said, infrastructure as a service, IaaS, from cloud becomes very handy. They give you the infrastructure and you set up your company's resources. That's your resources, and you set up your company's files in that resources, and everybody will use the same resource, everybody will store the same thing, and when the office is closed, a backup will be created. And that's the meaning of cold storage. Cold storage is the storage. You have seen when you're using some of these services, you receive an email that from that time to this time, the service will not be available. Mainly that inavailability is because of taking backups. So they're cleaning some stuff and taking backup, cleaning some temporary files, and that's the meaning of cold backup. So cold backup is when there is no service, nothing is being updated. I'm gonna take a backup, and then the service will be available again. Inexpensive, but restoring is uh, becomes expensive because now it's everything is in the cloud, and restoring becomes a little bit more complicated. We have data deduplication and single instance. Any backup system should take care of this. There shouldn't be duplicates of the same data. Um, and if you as a if the in the enterprise level especially, it becomes very important. In the enterprise level, there's a lot of information, so you don't want any of these backups be redundant. And there are, in enterprise level backup systems, there are options to set. Before they do the backup, they compare the data with whatever they have in their database, and if uh, something is just a copy, they make a single instance of that. So they merge the two files, or basically they just don't consider that as a backup because the data already exists. User level, be careful. We have in Windows, we have uh, I think it's I forgot the name. Restore. I think it's Restore. So you go back sometime in the time. You go back sometime that you had that your Windows basically had taken a snapshot of your system, and this way you can recover your data. But obviously, you will lose the data that has been created since that point. But before that, you will have all the information. Um, Mac Mac operating system offers a more efficient backup. You can take a backup every day, and these backups are kept in a in a in a queue. And if a new one comes and there is no space in that queue, the oldest one will be kicked out. We have Windows recycle bins are not backups, because They're unstable, they can be deleted easily, and because they are not in geographically separated area and they are in your computer, they are by no means backup, they are just copies. And synchronizing files with cloud storages like OneDrive is not backup unless that service, like OneDrive is like one of those, unless if you delete something from your computer, a version of that uh, is still is available on the cloud for a while. So for OneDrive, 90 days it's still there. So if something was mistakenly deleted, the it still exists in the cloud and you can go back and get it. So the best way, literally the best way to have a backup is to both backup locally and have backup on cloud. Like OneDrive is one of the best ones. Also, you need to have backup, your local backup in case no OneDrive is available. We all saw that when uh, last Friday there was Rogers blackout all over Canada, and phones, Roger Bay Fido didn't work, Roger Bay's internet didn't work. So, and I think it was more than 10 hours like that. So, in this case, if you need your files, a local backup can help. Um, as we said, different. Your backup should not be dependent on your system. It should be disconnected, completely disconnected from your system, and be stored in a separately in a geographically separated area. Final words. It's not the backup that matters. It's the restore that matters. Please restore sometime, take some time to see how you can restore the backup file. Sometimes you just take backups, and when it comes to restore, we don't even know how to restore those. It's important to be able to restore, and if you have backups that cannot be restored, they are not even backups. uh, okay, we are done. There are again more slides, but I leave them to you and you can check them if you want. We have some time to take a look at this week's activity, take a brief look, but I'm sure you need to go deep into that. Oh, by the way, before I forget, next week we will not have a lecture at this time, and since I don't think we all can agree on a time, uh, I will record the I will record a video and I will upload it to YouTube. And I guess I will do this with Big Blue Button, so the link of the video will also be available on Big Blue Button. But Wednesday, 11:40 next week, we will not have class. Like next week, we will not have any lecture like this because due to something unforeseen, I will not be available next week on Wednesday. So I will post that on our teams. You can go and watch that video. It will be just like this, except for it will only be me talking. Um, and also for presentations, if somebody still wants to give presentation, please go ahead and do that. The presentation part was not really welcomed from you, I think. But if you have if you're still thinking about presentation, please go ahead. Is there any questions so far? Okay. So the activity that we have is mostly about, the first part is mostly about uh, the encryption and compression algorithms. And here you will see some examples of what we saw in the lectures, finding redundant parts and putting the placeholder instead of those, and this way calculating the size reduction. So take a look at these examples. These are useful examples, and you will do the same thing on a song that you choose, and you will start compressing the number of words using this platform. This is the first part of the activity, and then all the questions, detailed questions about how to calculate the percentage that the percentage of reduction you have, and stuff like that, all the good things. In part two, it is about compression on the data file, on some of the data files and image files, and things like that. You will play with some of these files. We have image files. You will play with those and see the compression ratio and stuff like that. And part three is about backup, which you are very familiar with that. Uh, it will be questions about um, how backup works, what are the good things about backup, what is not considered backup, what is considered backup, and stuff like that. I think this is one of the interesting activities. Well, all of them were interesting, but this one is probably a little bit more interesting. It gives you spend some time. It has some details, and I hope you will learn, and you will learn a lot, and you will enjoy this activity. Um, if you have any questions, please ask. Otherwise, we might finish this week's lecture a little bit early, uh, if that's fine with you. Any questions one? Any questions two? Any question three? Okay. Have a great rest of the week and have a great weekend. We'll see you the week after next week. Take care.